Hello, everyone. Give me a thumbs up if you can hear me. We are here for another session of our Community Conversations Technomatics virtual user group. Today's topic is how to model a two-arm robot. So wanted to add some housekeeping. If you're first time with us, then nothing's different. If you've been with us for a while, we haven't been introducing all of this info. Wanted to let you know, obviously your cameras and microphones are off right now, but during the presentation, we invite you to react and use the chat feature, which you should see if you go to the menu at the top of your screen. For any questions or comments during the presentation, definitely use the chat. And then after the presentation, we always do the Q&A live. So you can raise your hand to be unmuted after the presentation. There's also a survey that I forgot our customer experience team asked me to pop in here. So I did throw that in. And then always, the recording is available on Friday. So that question comes up a lot. We always usually have the session on Wednesday, but we always try to have the recording available by the end of the week. So now, as you probably know, our presenter for this series is usually Mr. Stefan Bongso. And he is a freelance simulation expert. He's been in this space for decades and has completed hundreds of projects and training sessions. So Stefan has published 5 books on plant simulation. He's working on a 6th book, and he's one of the leading contributors to our Siemens PLM community. So welcome him. And our agenda, big steps for today: configuration. He's going to go through defining poses and programming of an assembly task. As I mentioned, we'll do the Q&A live after the presentation, so feel free to prepare a question and raise your hand. But of course, the chat is available to you during the entire session. That is it for introduction. So Stefan, feel free to steal the screen.
Hello again for next session. Okay, normally this session has 2 parts. One part is how to create all the joints and poses for the robot. But there is a really good video already in the Siemens. If you start your plant simulation, you have here area videos, and the video number 27 is how to create a robot, the kinematic of a robot based on a flat robot JT. If you export the robot from Process Simulate or download the robot from the vendor, then you get a flat structure of the robot. But I guess you know you need a structure with a hierarchy, and so you need to change the robot graphic to make it available for the plant simulation animation. And this video, Plant Simulation 27, is explain all the steps you need to do. And in I prepared this already for this robot here, and you can download it. You will find the link in the chat. You can download all the graphics we need for this example from the page from this community. Okay. Okay, we start with an empty file. And first I want to create the 2-arm robot. And first you need to think about what block from the library we want to use to create this robot. At least we need a capacity of 2, because we have 2 arms and we want to load 2 parts in parallel. And so one way could be to use a parallel station. But the parallel station, we get one problem. If you get to 3D properties and MU animation, we can only define one animation object per station, and so we cannot simulate the animation of two different objects with one basic block here. And so we need to select, or we need to choose another strategy to create a two-arm robot. Of course, you could model the two-arm robot by simulating, by creating two different robots and move these robots independently. But I want to show you one approach to create the robot as one object. So, okay, we need more than one object to create this this robot. And I want to create the robot using one block and two containers. The arms I want to model as containers, and then we need one building block to model the base of the robot. And in this case, I want to use the store for the base of the robot. So I duplicate the store and name it robot base. Because it can completely passive here in this case, because the robot arms doing all the job. And so I can use the store for modeling the base of the robot. And we need to change something here in the 3D properties because the store appearance is automatic by default. And so I switch off the auto graphics. And then I open this in a new 3D file. In the zip file, you can find three S3D files. I know you know this difference between JT and S3D. JT is only the graphics, and S3D files are special for plant simulation. It contains also paths and joints. And so I prepared also the base with the right positions of the MU animation points. Okay, so you can exchange graphics. Then you need to find the files. The first one is robot base. Okay, and that's it. This is the base of the robot. I skipped here two axes. It's one additional axis here in Y direction and Z direction, and one in X direction. I skipped this. I don't use this two axes here. Okay, and this is the base of my robot. And in this robot base, I want to create some user-defined attributes. X dimension set 2. It has already changed this here by importing this S3D file, because I have two animation points here, one left and one right. And I want to have two user-defined attributes. Arm L as object. Arm R as object. Then I want to have two controls, one control for arm left and one control for arm right. As method. One loading time. As time, you can set it to 5 seconds. And I need an init method here in this object. And the init method should create both arms and calls the control for arm left and arm right for the first time. And so I need first arms for the robot. Okay, this is my base, a capacity of 2. And next I want to have a container for arm left and one container for arm right. So this container has its own MU animation, and I can here edit 3D properties, define animation object, one animation object for each arm, and so I have 2 animation objects for the complete robot. I can also make 4 arms or more. And I need to change the appearance here of my robot, arm left. And so again, exchange graphics, and arm left is the graphic for the left arm. If you go here, mark the arm, it should be pink then, and right mouse click, edit 3D properties. Then you can see the joint. This one is a revolute joint. In X direction, this arm has 7 axes, and so it doesn't fit into the default configuration of Blend Simulation, with only supports 4, 5, and 6 axes, and this has 7 axes. And so I created some poses for this arm, and you can see this in the 3D properties. Poses, I create 3 different poses, one pick, one home, and one place. And I cannot use the Blend Simulation built-in move to coordinate method to move this arm to coordinate, because it doesn't fit in the basic structure of this axis here. Okay, the same for arm left, for arm right. Arm right, open it into a new 3D window, and then with Exchange Graphics, you can load the S3D file, and this is arm right. And this is, yes, the other arm. I changed all this structure. So into a hierarchy here, and this is the basic work you have to do. If you download such a robot, then you need to change the flat structure of the robot from the original graphic into such a hierarchy with animation or animatable objects at each element here. And for each element, you need to define a joint and a joint configuration. And here that's 1, 2, 3, 4, 5, 6, 7 axes. Okay, now we have 2 arms, and we have 1 robot base, and the arms are now MUs, and so if you reset the simulation, the arms will disappear because all the MUs will be deleted at the end of the simulation. And so at the start of the simulation, you will need to create the arms for this robot. But this you can do with an internal init method of this robot. And this should create the arms and start the controls for the arms. And so we continue with the robot base here in the class library. I want to save the link to the arms into my user-defined attributes, and the user I need to address this based on this init method, and so I need to address this with self location or self dot tilde. First arm L, and this you can drag from here to here. User objects arm L, point create, and the location is self point tilde. I want to create it on this object itself, and the same for robot arm right. I create robot arm right, and then I start the controls. And the same for the right arm control. Okay, then we can have a look if our robot is created in the right way. I apply the changes here, and then I place the robot into a frame, the robot base. Okay. And then you can start the simulation. And this is one typical thing in Plan Simulation, okay, it doesn't work in the right way because the dimension of the arms are not right. But you can change this with tools, calculate dimensions from 3D. Looks better. And the same for the right arm. Tools, calculate dimension from 3D. Otherwise, it scales your arms to the length, width, and height that it's setting here. Okay, now we have 2 arms, and we have already some poses. And now we need a basic scenario how to control this 2-arm robot. And normally this, or in many cases, such 2-arm robots are doing some assembly work. And so you can do the loading of the arm in parallel to the assembly of the other arm. And this gives some time advantages if you have very, very short cycle times. And so I want to create one assembly task. I want to have so I need to change the height here. And the base height should be 0.5 meters. This we need to change in 3D properties here in appearance 0.5. It's the base height of this robot, of this. So a second one, opposite direction. And this is for parts. So I need 2 sources, one source here for part E. A second source for part B. And then another conveyor here, 6 meters in front of the robot. And I want to create a box. And then one train. And then I have my basic setting. So if we want to download itself, this is a Yaskawa robot. This is the Yaskawa Motorman. Okay. We need to coordinate the left and the right arm here. And in this case, I want to use a sequence control. And for this, I need one variable. I call it just sequence. Integer, and the start value is 0. And to identify the box that's here, I need one more variable. Of type object. And this is the reference to the container that is stopping here. And I want to have a sequence of 4 steps. If the box arrives here, then start step number 1. And step number 1 is assembly of arm right. Then you can assembly this part on this box. And if he's finished, then starts the sequence number 2. Sequence number 2 is the left arm here, and it assembly the part into the box, and then starts sequence number 3. And sequence number 3 is that this box on the sensor, any tier sensor, then the box can start, and it starts a new sequence. This is a quite easy way to coordinate these 2 arms. And so first I need here on the conveyor, I need a sensor with a sensor control. Only some steps. I need to stop the box here, and then I set the link to container. And set the sequence variable to 1. And then I need to wait until sequence is 3. And then as I reset the sequence to 0. And the box can start again. It's quite easy. In this way, you can also create much more complex sequences with more robots here. If you have other robots that need to do some steps here in this sequence, then it's very easy to coordinate this with just one variable. Okay, and then we need to create 2 programs for the robot arms. I have already placed the control here in the basement of the robot. So we need to go here into the robot base, and we have already the robot control arm left and right. We start with arm right. Both looks quite similar. First, I need to move to the conveyor with the single parts, and I need to switch off the inheritance first. I have no condition here for picking the parts. Normally, you need more conditions to wait for a part. I don't want to do this here. We have the references on of the arms here in the user-defined attributes. Self.arm R is the right arm, and then it continues with underline 3D point process move to. And I show this to you. It's a pick. It's my pose I need to do, and you can specify a time. Maybe it takes 3 seconds. Then I wait the loading time. And then I need to look, what's this? This is conveyor. And I move this to arm right. Then I move to home. This is my waiting position for my sequence number. And I can now copy this, and the pose name is home. And then I wait for my sequence. And I need to wait for sequence number 1. So that means the box is on the right position. Then I can move in to the position of the box. And this is my pose place. Takes 30 seconds. I wait again for my loading time to open the clamps. And then I need to move the part from arm R to container. And at the end, I move back to home. And set a new number for the sequence to start the assembly of the left arm. And this is sequence number 2. And at the end, I call the method itself. To start the next cycle for the robot. It then can move to the load position, pick already a part while the other arm is assembled apart on the box. And so this is the process of the right arm. And this we can check. So he says, okay, self-loading time is not so I need to check the spelling here. Loading time with underline. Okay, I changed this in the class of robot base. Yeah, I change here. It's faster. Okay. It's inside the box. And this arm is on the right position and should not. Okay, now it's okay. The left arm should do the same. So I can take the robot arm program from the right arm. I just copy this all and move to the left arm control. I switch off the inheritance. And now I only need to change some points here. It's the left arm. I wait for the sequence number 2 for starting my assembly process. So it's all the left arm. At the end, the sequence number is 3, and then it should start from the beginning, left, left. Okay, so I change the size of the parts A and part B a little bit. Okay, and start again. Now both arms at the first step loads their parts. Okay, I have the wrong conveyor here, so I need to change this. This is conveyor 1. This is conveyor 1. So it's better to have different colors, and so we can see the failures quite easily. Oh, too bad. I don't have simulation stops now because it's no events anymore. I need to set here an interval for the boxes. I forgot this is 30 seconds. So I have some more events that because the oh, sorry. Okay, and sequence keeps 1. Oh, no, this is wrong here. I set the sequence to 2. Sorry, but it's live. At the end, I need to set the sequence and not wait for. And the same for the left robot arm. I need to set the sequence at the end. Okay, but now it should work. So, and now you see the effect of a 2-arm robot. You can do things in parallel, and so it can do many tasks faster. I can speed up a little bit. Okay, and so we have a 2-arm robot. It's not in your class library, but you can combine building blocks with MUs to create such more complex elements. And so you can create also machines with a lot of access using base equipment and a lot of containers or transporters to create access over access and create really complex behavior. Okay, any questions?
There's at least one in the chat. It says, why can't we take a parallel station instead of storing container?
Yes, I tried to explain it at the start. The parallel station has only one. You can set only one animation object here. You cannot move independently 2 different parts. It doesn't work. You can create animation paths and you can create a complex animation for 1 arm, but you have only 1 point. You can show the parts on the animation. You have only 1 animation object here. You can also, if you have a parallel station, you cannot have several animation objects here. And for the 2-arm robots, I need permanently 2 animation objects. Can this be applied to a worker? The worker has a very strange behavior if the worker is carrying parts. The worker tries to move the parts away to the destination, and you need to define a destination for the parts. And so theoretically, yes, but you have to fight with the default behavior of the worker then, and it's very hard to avoid the moving of the MU to its destination. So I don't think you can do this with the worker. Only for a certain number of seconds for a certain time span, yes, but not permanently. Why did you choose Baseplate as store only? Can you explain a bit more? This the base of the robot is really, it doesn't have a behavior. It just contains the arms, and you can you need one block with a place, a matrix-based place organization. This it depends on the animation structure here. It needs to be place-based, and so you can use the store, and you can use the parallel station. The parallel station is also organized in places. You cannot use, for instance, a buffer. The buffer is not organized in places, and so you cannot define animation structures like this one. I can show this here, the base, the 3D properties, MU animation. You need places here to get the right positions of the arms, and the arms should not move here. And this is only possible for place-oriented stations. The station here has only a capacity of 1, so you cannot use this. And then we have a parallel station, works, and we have the store. So you can also use the parallel station. Okay, make this blend sim both arms robot parallel activities like abstract output according detailed process simulate detail study. You cannot compare this to process simulate. We only move poses. We don't. You can also move single joints here, but normally we don't model the robots in this detail level like process simulate. You cannot compare this. It's a complete different level of abstraction. You can compare this with process simulate the level of compound operations. And if you have a look into the compound operations, you have your movements, you have the single operations like in the robot program here, but we don't have such different tasks like in the detailed studies. The sequence here is a global variable, and the sequence helps to coordinate left and right arm and the box. It's just a global variable here from the information flow, and all parts can have access to this global variable. The sensor control, the control of the left arm, the control of the right arm, all can have access to this global variable.
You should see on your screen right now a image of the Plant Simulation Virtual User Group forums. You can click on the link there. The animation is showing you to click follow and then to select every post using the envelope icon. So that will make sure that you get system emails whenever we post the invitation for the next session to register for the next session, and also the recordings. So again, Stefan said this will be posted at the end of the week on Friday, and that's also the previous recordings are also there. So the next 2 meetings, those are also clickable links if you're interested in either of those topics. On Wednesday, November 12th, Stefan will be back with various pool control methods. And on Tuesday, not Wednesday, Tuesday, November 25th, he'll be back with fluid library basics. That's the week of American Thanksgiving. So we'll have it a little bit earlier so I can get the edit done earlier and enjoy the holiday with family is the idea there. And then just 2 more announcements because I did see another question came through, and you can still raise your hand as well to ask a question. So let me do these 2 announcements. The Accelerator Academy team just wanted me to let everybody know that these courses are available. You can click through on any of those links to get over to Accelerator Academy. So it is a paid membership for on demand, or you can schedule live training. with that team. And then lastly, our customer experience team is like, please ask customers to take this survey. I had forgotten about it until a few minutes before we started, but you can use the QR code there. You don't get anything other than our thanks. We appreciate you. So if you're interested, you can do it. And then there's Stefan's contact information. The QR code for the survey is still there. The link to the forums where the recording will be on Friday is there. So those are my announcements. And it looks like Patrick has dropped a question in there also back about the robot. So if you need to still the screen, Stefan, you can do that to get that question answered.
Yes, okay. We are taking only 3 sequences right now. The sequence is only up to 3. 3 is releasing the box from the sensor here, and then it starts from 1 if the next box has reached the sensor. But it's not only 3 sequences. I can do here thousands. So it's only the sequence is up to 3. If you have another robot here or the worker has to do something, then maybe we need more numbers in the sequence or more steps in the sequence. Okay, a little off topic and maybe a little complex, but can you make this robot's movement as the processing time so that it can be recorded as walking time? You can record all the times as walking time. You can split it up to moving time and placing time, but it will not get any automatic statistics of plant simulation. You will need to record all these times by yourself, but you can easily do this in the ARM controls. You only need to record all the data. But the store itself doesn't have processing time. And so anyway, you need to calculate the time maybe for each arm. I don't know if it makes sense to have a processing time for the robot then. Yeah, it's difficult, but you need to make your own statistics. Okay, Albert, I think the program is following a sequence. So the next sequence is set when the current one is completed. Yes, it's the sensor control will reset the sequence to 0 and then starts the sequence again at 1 if the next box is reaching the sensor. So the sequence starts again anew. Okay, it's not only animation now. It's the real movement of the robot, but in the level of compound operation if you compare this with Process Simulate. And so you can really model complex robot tasks with several steps up to a tenth of a second, but not with each single step. But if you have the movement complete with 3 seconds, then a movement takes 3 seconds. And so you can, normally you do some such simulation in this detail to check the cooperation between all the several elements you have in these workplaces. And so it's not only animation, this is really simulation here. I need to say this.
It's a lot of good conversation in the chat. Okay.
If you want more complex movements for the robot arms, you need more joints. And I have already 7 joints here, but then you need the joints in the robot arm. If you don't have more, then it's difficult to animate this or simulate this. So you can only move in the joints you have in the graphics. And this robot, I have skipped 1 joint. This is in Z-axis of the robot base. And so, yes, you had one more joint, then you have 8 axes, and this is quite complex. already. Okay, it's now running this discussion with the statistics.
Yeah, it's good to see. I hope you guys are this active in the forums with all the advice. There's some good advice going in there about statistics.
Okay, I can make a webinar for such a user-defined robot and the statistics. You can create quite complex statistics if you want to have the statistics. Okay, how many times the robot is moving, how many times the robot is carrying a part, and what do the robot doing for tasks. It's all in your program. You just need to record the times. And so it's not really difficult to create a complex robot statistics, but we can make this also with a webinar. But there's no building statistics here you can use. Okay. Oh, thank you. And maybe until next time.
Yeah. It seems like everybody got their questions in there. So I just put up one last time. There's a link to Stefan's profile in the forums, a link to the forums. And if you were interested in filling out the customer survey, you can scan that and do that. So, but yeah, another thank you in the comments. I see Stefan's very helpful. All the applause. We appreciate you giving your time to assist.
Goodbye.
Yeah. See you all in the forums.
See you on the forums, yes.